Physics Part 404. The battery of EMFE is assumed to have negligible internal resistance. The output voltage V is given by the expression V is equal to S over S plus R into E. The magnitude V of the potential difference voltage at any particular value S of the sensing device is dependent on the relative values of S and R. Note that as the resistance of S of the sensor increases, the output voltage V also increases. By monitoring the potential difference voltage across the resistor of fixed resistance R, as shown in the figure, output voltage will be given by V is equal to R over S plus R into E. The output voltage will then decrease as the sensor resistance S increases. We've got an example for you. A potential divider consists of a battery of EMF 6.00 volt and negligible internal resistance connected in series with a resistor of resistance 120 omega and a variable resistor of resistance 0 to 200 omega. Determine the range of potential difference that can be obtained across the fixed resistor. When the variable resistor at 0 omega PD across fixed resistor 6.0 volt, when the variable resistor is at 200 omega, PD across fixed resistor is 120 divided by 120 plus 200 into 6.00, results 2.25 volt. The range is 2.25 volt to 6.00 volt. Now it's your turn. A potential divider consists of a battery of EMF 7.5 and negligible internal resistance connected in series with the resistor of resistance R and variable resistance of resistance 0 to 500 omega. Deduce how the potential divider may be arranged so as to provide a potential difference that may be varied between 0 and 3.0 volt. The operational amplifier. Once the output of sensing device is in the form of a voltage, it may require further change processing before it is used to control an output device. The basis of many circuits used for processing the sensor voltage is an operational amplifier or op-amp. An op-amp is an integrated circuit that contains about 20 transistors together with resistors and capacitors. It is referred to as an integrated circuit because all the components are formed on a small slice of semiconductor, for example silicon, with connections to enable the op-amp to be connected into a circuit. The symbol for an op-amp of some of its connections are shown in the figure. It is referred to as an operational amplifier because the circuit can easily be made to carry out different operations. These operations include acting as a switch when voltage reaches a certain level, amplifying direct voltages, amplifying alternating voltages, comparing two voltages and giving an output that depends on the result of the comparison. The op-amp has two inputs called the inverting inputs, minus, negative. The non-inverting input is positive, plus. For many applications, the positive and negative power supplies are plus minus 6V or plus minus 9V. Properties of an ideal op-amp. The ideal operational amplifier op-amp has the following properties. Infinite input impedance. No current enters or leaves either of the inputs. Think about connecting an input to one of the resistors in a potential divider. The input would be in parallel with the resistor and therefore the resistance in the potential divider circuit would be changed.